We are live. Hi everyone, welcome back to Codera. Today in this video, we'll be discussing the LeetCode daily challenge for today. That is 12th of Feb. The name of the problem is word ladder. Previously, this problem has been asked in a lot of organizations. Like it has been asked in Google. It has also been asked in Facebook. Apart from this, it has been asked in Amazon, Microsoft, Uber, and Adobe. LinkedIn also. So give me a +1 in the chat if my voice is clearly audible to everyone and the screen is visible, so that I can start as soon as possible. Also let me know if my voice is clear to all of you or not, so that we can start with this particular problem. It's a very interesting problem, and actually it's a hard problem for someone who is solving it for the first time. So all of you can just give me a +1 in the chat a little quick, so that we can start now without further delays in the stream, right? So this particular problem is based on two things. Basically what you'll be given is, you'll be given a starting word, and you have to convert it into an ending word. So you'll be given a starting word or a source word from which you will be starting, and then you have to convert it into the destination, right? That is, you will be given a word and you have to convert it into the desired word by taking some steps. We'll be discussing everything that's been mentioned in the problem. I'll just wait for a couple of minutes more for everyone else to join, so that we can start, right? So you can ask your friends to join, or all of you can just join a little quick, so that would help, right? Okay, so talking about this problem, so this problem, as I mentioned, its name is, you all can give me a +1 in the chat for acknowledgement purpose. Till then I am writing the details of this problem. So the name of this problem is word ladder, if I'm correct. So the name of this problem is word ladder, and previously this problem, as I mentioned, it has been asked in Google. It has also been asked in Meta, that is Facebook. Apart from this, it has been asked in Amazon, Microsoft. It has also been asked in companies like Uber, which is a very good one. Now it has also been asked in LinkedIn, right? So these are the top companies that have asked this particular question. So you can just give me a +1 in the chat for acknowledgement purpose, so that we'll be good to go with this particular problem, right? So in this problem, what it says is, you will be given a particular word, that is a source word. You will be given a source word. Let's say you will be given a source word, like here you will be given, let's say, hit, right? So it says that you will be given a source word. Let's say you will be given the source word as hit, and what you have to do is, you have to get a final word or a destination word. That is, you have to convert this source word, this hit, into the final word, that is cog, right? Let's say you have to convert it, right? You'll be given a string, you'll be given a word, right, starting word, which you have to convert to this ending word by following some steps that have been mentioned, right? So you'll also be given an array of words, right? So they are mentioning that you'll also be given an array of words. So they are saying that a transformation sequence from word begin word, that is the starting word, to the end word using a dictionary word list is a sequence of words where you convert this word S1 into S2, then like this until SK, right? Such that the adjacent pairs should differ by one single letter or one single alphabet or character, you can say. And what you have to do is, you have to do this in minimum number of steps. So let's say if I have this thing, let me write it for all of you. You can just give me a +1 in the chat for a little bit of acknowledgement, so that I know that everything is working fine, right? Differ by one single letter or one single alphabet. Okay, all of you can just consider giving me a +1, right? So if I say this particular problem, so what I'm saying is, you will be given a source word, like you will be given a starting word, you will have to convert it into an ending or a final word. But how you have to convert it, that's the trick that lies here. So let's say you have been given the starting word, that is hit, and you have to convert it into cog, right? This is the starting word, this is the cog, which is the ending word, and in between you will be given some words. So let me write those words for you. So the words that have been given is, let's say the word that have been given in the dictionary, just let me have a look. So the words that have been given is hot, dot, dog, lot. Okay, hot, dot, lot, and then you have cog, and then you have log as well, and apart from this you have what, hot, dot, dog, lot, log. Okay, these are the words that have been given to us, right? Hi Mahesh. So this is the starting word, this is the starting word, this is the beginning word which you have, and you have to convert this finally into this word, that is, you have to convert hit into cog. What you can do is, here the problem has mentioned that you can do it in one particular step. In one step, what you can do is, in one step you can choose any particular, you can choose this word, that is the current word, and you can change its one alphabet only or one letter only, right? So the final word is cog, that is perfectly fine. So I'll write it here that finally you want to reach cog, right? Finally you want to reach cog, so that is perfect. But what you will be doing in a particular step is, just let me write it a little bit more clear. So this is cog, right? Up till now, if things are clear to you, you can give me a plus one in the chat. So what I'm saying is, if you have this particular starting word as hit, right? So this is the starting word that you have. So what you can do is, you can change every time in each step, you can change one of its alphabets, right? You can change one of its alphabets or one of its letters. So what you have is hit, right? So you can choose one of its letters from the given dictionary that you have. This is the set of words that you have. So from these set of words, you can choose one. So what I'm saying is, you have HIT, right? So if you convert it into hot, so this will take one step. And why it is taking one step? Because you are changing one particular character only, one character or one letter you are changing in each step, right? So like you can see that you converted hit to hot, right? So this O, instead of this I changed it to O. So one character only I changed, one character or one letter only I changed, right? So that means that I have used this hot for the conversion part, right? Now next step what I can do is, I can convert it furthermore. So how will I convert it furthermore? So if I have to convert it furthermore, so do I have anything else? Yes, I have a dot as well, right? So I have a dot. So that means if I change this H and instead of this I make it HOT, I make it DOT. So that means I have made one more move. So I have made total moves that I have made is 2, right? Total moves that I have made is 2, and hot has been changed to dot. Please give me a plus one in the chat if up till now things are clear to you, right? Now next up, I am explaining the question part, the problem statement. Then we'll be looking like how we have to do this and what are the various things that we have to deal with. Now once you have lot, so what you will be doing is, let's say you have lot, right? Dot. So after this dot, you can say that okay, I can change it to lot. Actually here I have taken the words in this manner, but it's not necessary that you will be choosing line wise, so that's completely not necessary. So this dot changes to nothing but lot. One word is changed, so it changes to lot. After it changes to lot, so what you can do is, after it changes to lot, so you can change this lot to log, right? You can change this lot to log, so this would become log, and then this log L you can change to COG, right? C. So COG cog. You can take it cog from here and you can change it, right? So in the end, what happens is, from this particular word hit, from this particular given word hit, you were able to change it to cog by performing some number of operations. What are the number of operations what are the number of words that you had to change? First of all, this was the first word, right? Then this was the second word, this was the third word, this was the fourth word, this was the fifth word. So this was the 6 words, right? So in 6 steps, I was able to change it, right? 6 moves or 6 steps. Please give me a plus one in the chat and like the video if up till now things are clear to all of you, right? That in 6 steps, I was able to change it, right? You can just give me a plus one. That in 6 steps, I was able to change my word hit to cog, right? Like this, right? Is it clear to everybody? Like from hit to hot, one word change, that is H was changed, like O was changed. Then I changed this D, right? I changed this D, I replaced H with D. So one more word. Then what happened? Then I changed this D to L, so lot. Then I changed this T to G, like this here, so log. And then I changed this L to C, so COG cog, right? In 6 steps I was able to do this. Please give me a plus one in the chat if up till now things are clear to you, right? So in this way I was able to change. I took 6 steps to change it. Can I do something better than this? That is the challenge that lies ahead. So let's try and figure out whether we can do something better than this or not. So I'll just take a minute for erasing this part so that we can discuss further, right? Finally, you want to convert from hit, you want to go to cog, right? This is the target that you want for this particular problem. We can do this in 5 steps. Nikhil Jan is saying we can do this in 5 steps. How we can do this, Nikhil? Would you like to suggest us something? How we can do this? What I can do is, if I have the starting word as what? Starting word is hit, right? I have the starting word as hit, right? Yes. I have the starting word as hit, right? So if I have the starting word as hit, what I can do is, one more step that I can take is, I can maybe change it to, let's say, hot. First of all, as I said, I can change it to hot. So once this is one of the changes. So I'll be checking which of the words I have used, right? So I've used hot here. So I'll say, okay, I've used hot. I'll say, okay, I've used hot. Then what will happen from this hot? How will I try to change? Another thing that I can do is I can change it to dot. I'll say, okay, let's change it to dot. So I'll change it to dot. So I'll say, okay, I'll change it to dot. Now dot is also used. Now this dot, I can change this dot to nothing but dog, right? I can change this dot to dog, right? Hot to lot to hot lot. Okay, you are saying this. I'll come to this part. I'll come to your explanation as well. So from hit to hot to dot to dog, and then I can change this dog. I can change this D, and I can get cog directly, right? I can get cog directly from here. So I'll say, okay, I can get cog. So that means I have changed it. How many changes are there? This was the first word, this was the second word, this was the third word, this was the fourth word, and this was the fifth word, right? Hi Rajiv, right? So in 5 steps, I was able to do this part, right? In 5 steps, I was able to do this. Now what this guy is suggesting, this guy Nikhil is suggesting us, let's have a look at it. So he is saying that if I had something like a hot hit, so I can convert this hit to maybe something like a hot. I can convert this hit to hot. So I'll be checking that which are the words that are available, right? So if I'm checking, so I'll have these words, right? So what I'm saying is I'll choose it this way. So if I have hot, so I'll say that, okay, I have used hot. Then after hot, which is the word that he's suggesting? He's suggesting that we can use lot. Maybe we can use lot as well. So we will use lot. So we will use lot. Once we use lot, so this is the change. Then lot can be changed to log. So I'll change lot to log, and it changes to log. Then I can change log to cog, right? One word is changing in each step, right? So he's suggesting this, and how many steps it is taking? So this is one transition, this is second transition, this is third transition, this is fourth transition. Basically 4 plus 1, that is 5. So basically 5 words are there. So from hit to cog, there are total 5 words that have changed, right? This was the first word, this was the second, this was the third, this was the fourth, and this was the fifth. So there can be 2 optimal ways. Like you can do it in 7 steps as well, but you can do it in 5 steps. The best that you can perform, the minimum, the shortest time, the shortest path which you can follow to convert it is 5 steps, right? Please write agree in the chat or give me a +1 in the chat if up till now things are clear to you, right? That you can do this in 5 steps, right? You can do this in 5 steps. Either you can convert hit to hot, then hot to dot, then dot to dog, and then dog to dog to cog, right? Or you can change it to hot to dot, hit to hot, then hot to lot, and lot to log, and then cog, right? So this is the problem statement. You are saying you use dog, but dog is not available. Okay, dog is not available. Let me see, let me check. Dog is available, man. Dog is actually available. Sorry, dog is actually available. Dog is actually available. So this is the part that I've missed, but actually here dog is available. So 1 2 3 4 5 6, yeah, there are 6 words. So dog is available actually. Actually dog is available, right? So Nikhil, I just made a mistake. Dog was available, that is why I was using it, right? So dog is actually available here, right? So this can be one of the ways, or this can be one of the ways. So basically the minimum number of steps that I can take is 5 steps, right? So now the thing is that how do you see the pattern, right? How do you decompose this particular problem, right? So this is nothing but if you will try to observe this problem, so it is nothing but a graph problem. Why? There are 2 reasons for this. First of all, it is asking you the what is the question asking you? The question is asking you shortest transmission sequence, right? So question is saying what is the first thing is to observe that why it can be a graph type kind of problem, because it is asking you the shortest path. Indirectly it is asking you the shortest path to convert the starting word to the end word, right? It is asking you to find the shortest path to convert the starting word to the ending word, such that you are using the words that have been given to you in dictionary, right? This is not a DP problem, right? Because you have to find the shortest part, so it will be graph based, not DP based. Nikhil, I hope that everyone is able to understand. Please give me a +1 in the chat if up till now things are clear to you guys. You guys, are the things clear, right? So if I have a start word and if I have an end word, so I have to convert my start word into the end word by taking minimum path, shortest path, right? Shortest path, right? So if the path length is 4, so the steps would be 5. If the path length is 5, then the steps would be 6, like this, right? So this is the thing. So I have to convert it using the shortest path. So I can see that this gives me some hint of a graph kind of situation. I'll try to decompose it further. I'll try to, this is the first hint that we have got, that okay, this might be something related to graph, because as we saw, like there were a lot of paths, like from a particular start I could go this way to this, or I could go this way to this, right? There were a lot of paths, right? There were a lot of ways to reach the ending word. So that's what we are also expecting. So that's why I can see that there is some smell of graph here, right? Now next up, another thing that I need to observe is that how can I see that there is a graph, right? So if I will first of all have all the words. So in the dictionary, what words I am having, let me write them. So in the dictionary I am having, I guess, dog, I am having dot, I am having lot, I am having log, I am having cog, and I guess I am having another word. Let me just check it. So which is the word? Dot, hot. Yeah, I am having hot as well. Yes, so I am having hot as well here. So in the dictionary I am having these words, right? I have dot, dog, dot, lot, log, cog, and hot, hit, hot, right? So these are the words that I'm having, and the start word for me is nothing but hit, and the end word is cog, right? First things, what are you saying, Rajiv sir? Please, constructive algorithm. I have gone through greedy series. Okay, very helpful. Eagerly waiting for constructive algo and implementation series of codeforces. Please, sir. I'll start it as soon as possible. Rajiv, thank you a lot. Thanks a lot for compliments. I'll try to start it as soon as possible. I also have a mini series in which I have taken 3 sessions, so you can also consider to watch it, right? So let's come back to this problem. So the starting word is hit, ending word is cog. Let's try and observe. Right? Let's try and observe what are the paths that we could take, right? So if I have, let's say, hit, right? And if I have here cog, right? One way to do it, like, let's try and figure out. So let's say, what are the words that I'm having here? Let's say I have hot. Let's say I have something like a dot here, and I also have dog here. Let me write lot in here, and let me write log here, right? So this is the way that I'm writing it. Now you will observe that what is the thing that's happening, right? All of you can just consider it like this video. Now you will observe one thing here. What can you observe? So if I see that there are paths, right? So this is the source, this is the starting point, this is the starting point, right? This is the starting point, and this is the ending point. Now I have several paths to reach it, right? And going to one path, how am I going to one path? So I will take this path. I will take from hit to hot. I'll take this path only if I'm changing one word, right? I cannot take this path from hit to dot, right? I cannot go from hit to dot. Why? Because here 2 words are changing. H and I both are changing to D and O respectively. So that's why it's not it's not something that's mentioned in the question. The question is mentioning that you can change at most one letter or at most one alphabet, right? So HIT hit, then HOT hot. So I'm changing I to O, right? Then LOT lot, LOG log, right? So I'm changing T to G, right? Something like this is happening. So this is what I have to observe. I have to take the paths in such a way, in such an optimal way, such that I have to change only one word, right? So I can say that from hit I can take hot, from hot I can take the path dot, right? From hot I can change it to dot. That's why I'm making edges, right? Now consider the words that I have as nodes, and the edges is the connection, right? Edges is the connection, valid connection, that is from a particular word. If I can change only one of its letters, so that's why I'll mark an edge between those two, right? Those 2 words, right? So this is what I would do. Now if I have hot, so I'll connect it with this, then dot and dog will get connected, then dog and cog also one word is only difference is there, right? Only one letter difference is there, so that's why I'll connect these as well. Then log and cog will get connected as well, then lot and log will get connected as well, and this can also get connected, hot and lot. Then this can also get connected, and similarly this can also get connected, right? Does this make sense? How am I making the graph, right? How did I figure out a graph, right? How did I figure out this particular graph? Is this much part clear to everyone? Please consider giving me a quick +1 in the chat if you are able to see how did I constructed this particular graph, right? A quick +1 in the chat from all of you could help, right? Is it clear to everybody? A quick +1 in the chat and like to the video would help to understand, right? What I did was I connected from a particular word to another word. I connected an edge if I was changing just one word. All of you can just give me a +1 in the chat, right? Hi Shreya, thanks a lot for the plus one, right? So I connected the edges if I could change one. So like hot and lot, I connected an edge between these two because there is a path, right? Because only one of the letters is changing, right? Only one alphabet is changing. H is changing to H. L, right? Similarly, since in this dog, I'm changing D to L, right? So DOG, LOG, right? So this DOG, COG, right? So this is the way. Now I can easily see this part that I can easily see that what I have to do in this part is I can easily see in this particular part that I can find the shortest path, right? If this is a graph that I can easily observe, that I have deciphered, I've found out, I have observed that this is a graph. So in this graph, I can easily see that I have to find the shortest path from the source vertex, that is from hit, that is from the starting word, to the destination, that is cog, right? Is this much part clear to everyone? Please give me a plus one in the chat if this much observation is clear to everyone, right? I hope that this much observation is pretty much clear to everybody, right? Is it clear to everybody, right? Right, is it clear to everybody? Now tell me one thing. If you want to traverse in a graph, right, you want to find the shortest path, right, in the graph, to convert this, to go from this starting word, that is from the source word, that is hit, to destination cog, right? This is something that you want to do. Tell me one thing. There are two ways to traverse in the graph, right? There are two ways. One is a DFS, another is a BFS. Which algorithm, thanks a lot Harsh Mishra, which algorithm is used to find the shortest path in a graph? Which algorithm will you use to find the shortest path in a graph? Which traversal will you use? Will you use DFS or will you use BFS? For finding the shortest path in this graph from the source vertex to the destination vertex, all of you are saying BFS. Why not DFS? The thing is, I'll come to this example, but first of all, let's have some discussions, right? Let's have some quick discussions. What I'm saying is, for finding the shortest path, right? Shortest path from source to the destination word, right? This is what you have to do. Now, there are two types of traversals that I can do. There is one DFS and there is one DFS. And I want to find the shortest path, right? Some people are suggesting that I can do a BFS, right? So now in this particular thing, one thing that I need to observe, let's say if I had something like this, let's say if I had I'm making some notes, basically notes I'm making, right? I'm making some notes. So suppose this is the source node. Let me make some notes here also, right? Let me make some notes so that we can decide whether which algorithm will be better, DFS or BFS, which traversal would be better. Like let's say this is connected to this, then this, something like this, and then this, right? Suppose this is the destination, right? This is the destination. Suppose this is the destination that I want to reach from the source, right? Suppose this is the destination that I want to reach, and let me make some more edges here. So I'll make it for you guys. I'm making basically a kind of a graph. So another thing that I could do is I could connect something like this to this, and then this, right? Suppose that I use a DFS. Suppose if I'm using a DFS, suppose what will happen if I use a DFS? If I use a DFS, first of all, I'll go to this path. Suppose if I'm using a DFS and I'm traversing this path, suppose if I first go to this path, then I go to this path, right? Then I traverse this path, then I traverse this path, right? Then suppose I traverse this particular path, then I traverse this path, and then I finally reach the destination. Is this the shortest path? Is this the shortest path? Because this length is what? This length is nothing but 1, 2, 3, 4, 5, 6. So total I have covered 6 edges, so that means 7 nodes, right? So 7 is the number of steps that I have taken for converting the source word to the destination word. This is very important to understand, that why will you choose a particular algorithm, that is DFS or BFS. When you are in an interview, the interviewer might ask you why you are using a BFS or a DFS if you are using any of them, right? So you have to give a correct reasoning, a logic and a valid logic. You have to give it. So if I do it this way, so I can find it in 7 steps, right? But in DFS, I can see that, okay, this would be one of the parts, right? But instead, if I am here, right, I reach here, then I'll try to backtrack from here, right? I'll try to backtrack. I'll go to other paths as well. So let's say I'm backtracking, right? I hope that the concept of backtracking in DFS is a little bit known to you guys, right? Because if I'll explain backtracking here, it will take a lot of time, right? So another thing that I could have done is I could have maybe taken this particular path, something like I could have started from here, taken this path like this, and maybe then this, then this, then this, then this, and then this. So this path is what? 1, 2, 3, 4, 5, 6, 7, 8. So that means 9 steps, right? So this path is also taking a lot of steps, right? This path is also taking a lot of steps. Just hold on with me. Just give a like to the video. Hold on till the end. You will understand everything crystal clear, right? Now in this particular path, I can see that the steps are 9, right? So I'll backtrack again, right? The backtracking concept will be there because I'll try to search for all the paths, right? I'll try to find the minimum possible path here, right? This is what I will try to do. So I'll say, okay, maybe this is not the path. So what I'll try to do is maybe one of the paths that I'll traverse is this path, that is from here till here, then here till here, and then here till here, right? So you can see that I could do it in 4 steps. I could reach the source to destination in 4 steps, right? Can you see in DFS? Can you see in that DFS that because of the backtracking that I have to do, because of the thing that I have to traverse every path to find the shortest path, right? I have to traverse every path to find the shortest path, so I have to do a lot of backtracking and things like these. So that's why it would be exponential. It would be the cost of doing DFS, cost of applying DFS on this particular graph would be exponential. I hope that you can sense that, right? Is this much part clear to everyone? Please write clear or a +1 in the chat a little quick so that I can move further, right? So if I'm using DFS, then I have to come back from this path as well. Although this is 4, but I need to traverse all the rest of the paths as well. So maybe I need to traverse this like this, then go to this like this, right? I might need to traverse this path, right? This path till here, then here, then here, then here, this path, right? So I need to cover all the paths using the concept of backtracking, right? Using the concept of backtracking, you can write up clear in the chat if up till now things are clear, right? So I need to use the concept of backtracking while I am applying DFS to traverse all the paths and check the length, right? So it will be exponential, right? It will be exponential because I'll be traveling a lot in this graph, right? It will be exponential. But if I will use a DFS, if I will use a BFS, right? So since it is a level order traversal, it's a level order traversal, right? So you know that BFS is used to find the shortest path. But what is the reason for it? The reason for it is this only. That in BFS, what will happen when I'll apply BFS? So I'll be traversing this path only, this path. This path I'll traverse, right? I'll see the distances. So this is 1, right? Then this and then this. So in BFS, I'll directly get this particular path. If I'll apply BFS, then BFS is what? It is a queue based, it is a level order traversal, right? Since it is a level order traversal, so the levels that are nearer, first I will be covering those levels. Like this path will come very later, and before that I would have reached my destination, right? If I cover this particular path, that is let's say this and then this. So it will not, BFS will not cover this path first. BFS will, since it is a level order traversal, so it will cover this particular path and help me to reach the destination, right? So that's why BFS is more optimal. That is why we are using a BFS, because BFS will do it in order of n time, something like a linear time or a polynomial time complexity, it will do it. But if we were using a DFS, so since we had to use the concept of backtracking for checking every path and things like that, because we would not be sure that whether the path that we are getting is the smallest one or not, so that's why we need to do the concept of backtracking and things like that. So that's why BFS would take us a lot of time, hell lot of time. So that's why you will not apply DFS, because DFS would be exponential here, and you will use BFS instead. I hope that this particular explanation and logic is clear. You can give your +1 in the chat. Now I'll be moving forward to the further explanation, right? Let's come back to this particular graph, right? Let's come back. So this is the graph that we had, right? I have to find the shortest path, right? Let me just make some space for us. So we have agreed, all of us have agreed that we can use the concept of a DFS, right? All of us have agreed that we can use the concept BFS, right? BFS can be used, sorry. Okay, so this is nothing but dog, right? So this is the graph that we have. Let me make some space for us to work, to do the dry run part, right? So this is the graph that I'm having, right? Up till now, everything is clear, right? Now I'll apply a BFS. Now how will I apply a BFS, right? How will I construct edges? Will these edges be constructed earlier? No, that will not be the case. I'll be constructing it one by one. The graph initially would have just words, right? So I need to find the shortest part, right? So I'll apply a BFS. What I will do is, first of all, just do this part, right? Let's erase this part and let's understand what I'll be doing, right? What I will do is, notice very minutely, just notice. First of all, I have the word hit, right? I'm drawing it down. First of all, which word I have? I have the word hit. Now, which are the probable chances that I can convert hit to, right? Which are the first level connections of hit? Either I can change hit to hot, that is, I can change one word, I can change this particular word. So I'll be checking for every word, right? I'll be checking for every word. I'll see if I can change H, right? If I can change this H. So do I have something like a lit or something like that? No, I don't have, right? So that's why I cannot change this. Can I change this, right? T. If I keep this H and I same, can I change it, this last word, last letter? I cannot do this, right? So that's why I can just change this I to O, right? This is one of the path from this, right? So I'll say, okay, this is only this is the one of the paths, right? So in the queue, what will happen after hit? I'll have hot, right? Inserted in my queue, right? Is this much part clear to everybody? I hope that it's clear, right? All of you can give me a +1 in the chat, like the video as well. Keep communicating, guys, in the chat so that I can understand that whether you are understanding or not, right? So I'll be checking for each word. For each word, I'll be checking for all the 26 alphabets, right? So that is something that I'll be doing. That whether I can, I will check that whether I can make a combination of hot, whether I can make a combination of anything else or not, right? Things like these. Which words are present, right? So that's why. So like this will be the dictionary that's available to me. This is the collection of words that is available for me. So if HOT hot is available, so I have used it, right? So I'll say, okay, I have used hot, right? Now I'll not be using it once again, right? I cannot use the same words again and again, right? So that is one constraint in this problem. Now I've used hot. From this hot, right? From this particular hot, which are the words that I can convert it to? I can change this H to this D. So I can change one word. So this means that there would be an H between this and this. So that means for this hot, for this particular hot, I can insert dot and I can also insert lot. Why? Because hot and lot. So I can insert these two, right? So these are the connections that I'm making, right? Right, but the things would be going in a BFS manner, right? Now what will happen? Let's suppose that I have this thing, right? So now currently I would be at this, right? I would be at dot, right? I would be currently at dot. If I'm at dot, what will happen if I'm at dot? So if I am at dot, so what I can do is I can change this dot to dog, right? I can change this dot to dog. So I'll change this dot to dog. So that's why I'll insert dog here, right? So I'll say, okay, dot is changed to dog. Then what I can do, can I change this dot to anything else? I don't see anything else with which I can change it. So I'll say, okay. I'll say, okay. So currently this is the path. I'm here. Now what will happen? I can change. Now what will happen? I'll be at this log, right? I'll be at this particular log. I'll be at this particular log, right? I'll be at this particular log because dot is done. So all these things, all these previous things would be taken out of the popped out of the queue, right? So I'm not popping it out for the understanding purpose all of you. Now I'll be at lot. So lot can be changed to what can happen, like for dot also I could have done this, right? So for lot also, this thing I could have taken lot also, right? Okay, now the thing is that which are the words that I've used? I have used a lot of words, right? But let me see. So I can convert it to this, right? So I need to add log in my queue as well. Things like these I will be adding, right? But when I'll come to this dog, right? When my front of the queue will be this this particular dog, I'll have a lot of paths for sure. But BFS would be helping me to traverse the shortest path. So if I'm at dog, so dog will help me to go to cog, right? Dog will help me to go to cog. So if I can go to cog, so since I'm using a BFS, so that will help me to, that will say that, okay, this is the shortest path. And what will happen? I'll say that currently my level is 0. Here I'll say that, okay, my level is 1. Here I'll say that my level is 2. Here I'll say that my level is 3. In the end, I'll say my level is 4. But the level here is 4. Here the level was 0. Here the level is 1. Here the level is 2. Here the level is 3. Here the level is 4. This is the word that I have reached to, right? I'll be erasing all these words one by one once I'm inserting them into the queue, so that I do not do them repeatedly, basically marking them as visited, right? Basically I'll be marking them as visited so that I'm not stuck in an infinite kind of loop kind of situation, right? So what I would be erasing them from the map. That is something that I will be doing. I hope that that much part is self-explanatory, that once you visit a particular node, so you'll be marking it as visited. What's the reason for that? The reason for marking it as visited is because we do not want to be stuck in an infinite loop, right? So from here what I will do is, I can see level 0, level 1, level 2, level 3, level 4. But is 4 the answer? No, 5 was the actual answer. Why? Because hit, hot, dot, dog and log, right? Let me write it. Hit to hot, 2 words, right? Then hot to dot, third word, dot to dog, fourth word, and then dog to cog. So this word, right? So if my level is starting from 0, so the answer would be level plus 1, right? If the level is starting from 0, right? Please give me a plus 1 in the chat if up till now things are clear to you, right? Or is everything clear to you? Is everything clear to everyone, right? Just let me know in the chat, right? This is what I'm doing. Is everything clear to you guys? Please write clear in the chat, or please give me a plus 1 in the chat if things are clear. Also, you can consider to like this video, right? Is everything clear to all of you? I hope that it's clear, right? The intuition behind it. Basically, we are running a BFS, right? We are running a BFS, and whichever nodes are present at the same level, will be running the loop for them at one time. Like hit is only present at the first level, but at the second level, I only have hot, right? I only have hot. But on the third level, from hot, what I can do is, from hot I can go to dot and log both, right? So that's why these two will be on the same level, right? So that's why I'll be traversing for these two. Then dog, lot, and this thing, all these things would be together like log, right? So these would be at same level, right? Please give me a plus 1 in the chat if things are clear to you. Now let me show you the code how we will be doing it. So what we will be doing is, I'll show you for better understanding, then we'll come back to this particular thing, right? Showing the code part is important, otherwise you might get a little bit stuck somewhere, right? What I will be doing is, I'll be given the beginning word, I'll be given the ending word, I'll be given the vector of the strings, that is I'll be given the word list, that is the dictionary that I'll be given, right? In which will be storing the words. I'll mark all my words into my map, in my map, or in my unordered set, I'll mark them, so that I can keep a track that which words I have visited, which words I have not visited. If you don't want to use a unordered set, you can also consider to use something like a visited array, right? Then what I'll be doing is, I'll be marking bool is present as false. So initially I'll think that my destination that I want to, initially I'll think that, okay, cog is not present. So if cog is not present in the map, then in that case, the final destination that I want to reach, if that is not present in the map, if that is not present in the word list, then I'll always return a no, right? So I'll be inserting every word, into my set or into my map, you can say. And what I'll be doing is, if the final word that I want to reach, if it is present, if suppose cog is not present, in that case there will be no meaning of making a graph, right? Because like you will never be able to reach the destination, that is cog, because cog will not be present if cog is not present in your dictionary list, right? So that's why if cog is present, so you'll mark your flag or is present as true. Now if your cog is not present, if the destination that you want to go, how will you do bidirectional BFS? You can do this using a bidirectional BFS as well, but this is a better approach for doing this, right? Biram, you can after this chat is over, you can let me know how you are thinking it to do bidirectional BFS. But if I'll explain both the things, so it will take a lot of time. Already I've taken a lot of time, so that's why I will not be able to take bidirectional BFS. I know that it can be done using that approach as well, but this is much more simpler to think, right, and explain as well. Okay. This is much more intuitive, right? You can do this using bidirectional BFS also. That's perfectly fine, right? So if the word is not present, if the destination, if let's say the cog word is not present in my dictionary, in the words that have been given, so in that case I'll return a false or 0, right? Otherwise what I'll do is, I'll have a queue of strings, I'll push back the beginning word, and I'll mark my depth or the level as 0, right? Level as 0. Then I'll be running until my queue is empty, right? If my queue is empty, until my queue is empty, right? So I'll run it, right? Standard BFS template. So what I'll be doing is, I'll be increasing the depth at this particular level, and then I'll calculate the nodes which are present at this particular level. At the current level, whatever nodes are present, like you can say, right, I had some nodes which are present at the same level. Let me show you like this, right? I could say that how will I change the level? I'll not keep on updating the level every time, right? I need to change it only when I'm changing the level. So some nodes will be present at the same level, like hit is present at the level 0, then hot is present at the level 1. Then what is happening, dot and lot is present at the level, this is level 0, like this is level 1, this is level 2. Then these all these things, right? All these things, these are present at the level 3, like something like this, right? So that's how I'm changing my level. Would be Won't be the complexity better? Yes, it can be, like starting BFS from start and end simultaneously. Again, that can be the approach. I'm not neglecting it, but if you are a beginner, if you just see this question, so I'm decomposing it like how you can go forward in an interview, right? I'm assuming that you don't know anything. If someone is knowing bidirectional BFS, if you want me to make a video on that, you can comment down after this video. I can do the solution using bidirectional BFS as well, but not in this video. It will take a lot of time. It will kill a lot of time for others, right? So what I'll be doing is, I have all the notes that every time I am changing a level. So every time I am changing a level, what I'll be doing is, I'm doing this, like I am currently having the level size. So I'm just, every time I'll not be doing the depth plus 1, right? Every time I'll not be incrementing my level. Why? Because whenever the level, all the nodes in the particular level are traversed, only then I'll be changing my depth, right? Only then I'll be increasing my depth. So that's what I'll be doing. So I'll calculate the level and I'll run a while loop so that I do not end up incrementing this depth every time, right? So what I'll be doing is, I'll run for all the level size, that is for all the nodes that are present in this level. I'll be running a BFS. So in the current, I'll store the q.front and I'll pop the current word out. After this, what I'll do is, the current word is there, right? The current word is there. Let's suppose that the current word is nothing but hot. If the current word is hot, so in my temp I'll store hot, right? In the temp I will store hot, right? After I have stored hot, so I'll try to change one character each time, right? I'll try to change every character. So first of all, I'll try to see whether AOT is present or not. Then I'll try to see whether BOT is present or not in the dictionary. Then I'll try to see whether COT is present or not, right? This way I'll try to see. So after that, I'll check for the second letter. I will try to see whether like things are like these are present or not, right? So whether lot is present or not, right? Something like this, right? I'll try to see. Like I'll try to change in this way, right? Is this much part clear to everyone, right? I'll try to see like hog is present or not, things like these. Every time, for every word, for each and every position of the words, I'll try to see, I'll try to fit, I'll try to see if that particular word, is basically if it is not present, right? So in that case, I'll continue. Otherwise what I'll do is, if it is present, right? If what happens is, if the particular word that I am at, right, if the particular word that I have made, let's say from log I have made cog, right? If from log I have made cog, so the moment I make cog, right? The moment I make cog, so that is what I'm doing. Temp.compare the end word, right? So cog.compare cog would give me 0. So the moment I get cog, at that particular moment I need to return to depth plus 1, right? Because I'll stop my BFS. Simply I need to return to depth plus 1. So the answer would be nothing but 4 plus 1, that is 5, right? For the cog part, I hope that you can relate it, right? Now if that particular word that I've made, if the temp word that I've made, if it is present in my dictionary, right? If it is present in my dictionary, then let's say I've made what? Let's say from hot I have made lot, right? I've made hot. From hot I've made lot. So in my temp I have what? Currently in my temp I have lot, right? So in my temp I have lot. So I'll check whether this lot is present in my dictionary or not. Whether it is present in my dictionary of words or not. If it is present, then I'll push it into my queue and I'll erase it from the map. Basically, I'll mark it as visited, or you can say I'll erase it from the map. Now after this, the BFS would be over. Every time the level would be keeping on changing. And if you can reach it, so in that case you will always be returning the depth plus 1. If you make a temporary, if you can convert it to a string, if you can convert it to a word such that you can reach the end word, in that case you will return the depth plus 1, right? Is this much part clear to everybody? Please give me a plus 1 in the chat if this much part is clear to everyone, right? You can consider to give me a quick plus 1, right? A quick plus 1 from your side would help, right? So now what is the time complexity for this particular approach? That is something that we need to understand, right? That is something that we need to understand. Please give me a plus 1 in the chat, Shreya and others, and Harsh, all of you can consider to give me a plus 1 in the chat, right? So now what is the time complexity for this particular code? The time complexity for this particular code, let's try and analyze, right? So let's suppose that a particular word is of length n, right? The length of a particular word, since every word is having the length n, right? Every word will be having the length n. So the length of the word is n, right? So for every word, can I say that for every word, I'm making all the possible for every word, right? For every word, for each and every word, I'm checking for all the 26 alphabets, right? For each and every position, right? So I'm doing this, right? Is it clear to everyone? For every word, for every one third of length n, right? for one position. For a particular word, let's say hot, for this particular word I am checking for 26 positions. For this I am checking for 26 alphabets. I'm trying to generate all the permutations, right? So that I can check whether that particular the thing that I've generated, whether it is present in the dictionary that I have been provided or not. For this also I am generating 26, right? So that means nothing but length of the word, that is n into 26, right? So this much part would be clear, right? So that means n into 26, right? Now another thing that I am doing is I'm comparing it every time with the final word, right? I'm comparing the word that I've made with the final word, so it would take order of n time. So that's why n, you multiply n as well, right? Now another thing is there, that in the worst case, let's suppose that at a particular level, there would be levels, right? There would be some words present at the particular level, right? Some words would be present at each level, right? Let's say this one, the many number of words, some words would be present at each level. So let's suppose that the maximum of m words are present at a particular level. So in that case, in the worst case, this m would get multiplied, right? So in the worst case, this would be the time complexity, order of n into 26 into n into 26, right? This I'm using for generating for each word 26 characters. So for each particular letter, for each particular index, so that since the length of the word is n, so n into 26, then ny because I'm comparing it with the final string, that is cog. I'm comparing every term that I'm making, I'm comparing it if it is present, or then I'm comparing it with the final word. Apart from this, if there are m words present on a particular level, so I need to multiply m as well, right? Because I'll be doing, in the worst case, I'll be doing for this is for one word, right? This is for one word, right? This n into 26 into n, right? But if there are m words on a particular level, so I'll multiply m as well. So it would be nothing but n into 26 into n into m, right? So it makes sense. Please give me a +1 if this much part is clear. So this was the Java, this is the Java code for this particular problem. It's exactly the same. Basically, you just make it and then you keep on removing the top. You keep on checking, if you reach the particular word, then you will return level +1, things like these. So it's very similar to that. You can just give me a +1 in the chat if everything is clear to all of you. And that is how we do this particular problem. So this problem, as I mentioned, it was asked in Google. And it was, you can give me a quick +1 in the chat if everything is clear to all of you. Also, you can consider to like this video, right? So this particular problem, as I mentioned, it was asked in Google, it was asked in Microsoft, it was asked in Amazon, it was also asked in Uber, it was asked in like which company, LinkedIn also, right? LinkedIn also. So a lot of companies have asked this particular problem. So that's why you should solve this particular problem. Try to implement it yourself. I have told you a lot, like how I have told you everything about this particular problem. If I'll give you a brief summary, so I've told you like how do you check that whether this is a graph problem or not. So I've told you like what is the intuition for drawing a graph, then the intuition, then after that we have to find it, since this is a graph, so we have to find the shortest path in the graph to reach from the source word to the destination word. And there could have been two ways to do it, either DFS or BFS, but doing DFS, backtracking and things like these would have taken a lot of time, consumed a lot of time, it would have been exponential. So that's why we neglected BFS and we went with the BFS, because BFS gives us the shortest path from source to destination in any given graph if the weight of the edges are equal, right? So that's why I took BFS. And then time complexity was n into 26 into n into m, where for one particular word, let's say for hot, for this particular word you are checking for 26 situations, right? You are checking here for 26, here for 26. So this means n into 26. Then what is happening? You are checking, you are comparing it with the final word, so n multiply as well. And then if there are m words on that particular level, so n into 26 into n into m, right? Please give me a +1 in the chat and please like the video if up till now things are very much clear to you, right? So this was the problem, word ladder, as I mentioned. So try to code it. I've provided the C++ as well as the Java code in the description of this particular video, so you can try to check it out. So it's just how you decipher the graph problem. So this was a graph problem and you just had to find that, okay, this is the shortest path that you have to find from source to destination. And why you will not use DFS, I've told you, I'll provide the timestamp for all those things after this video is over. So that's why we have applied a BFS. I've told you about the time complexity, space complexity, everything, and how we are writing the code, approaching the code for it. I'll just go through the code once again. Basically, I'll be, first of all, I'll be having a visited array or a map or a set in which I'll be storing all the words that have been given to me. I will initially think that, okay, the final word is not given in the dictionary, so I'll traverse through it. I'll insert all the words into my map or a set, right? After that, if the final word that I want to go, that is cog, if I want to go to cog, if cog is not present in my word, so in that case what I'll do, if cog is not present, so I'll simply say that, okay, since cog is not present, so I'll return a 0, right? since cog is not present, I'll return a 0. Otherwise, I'll definitely start my BFS. So I'll push the first word, I'll mark my depth as 0. I'll run until the queue is empty. So I'll mark my depth is equal to depth plus 1. And every node which is on the same level, I'll be running a while loop for them. So for the same nodes, I'll be processing them at the same time, right? So that every time I change the level, so I'll be doing depth is equal to depth plus 1. So what I'll be doing is I'll be taking out the current word. Then I'll be doing the operation, that is for each word I'll try to make all its combinations, and I'll see if I'm changing a particular letter so that particular temp is present in the dictionary or not. If it is present, then perfectly fine, I'll push it into the queue. And if I make the temp in such a way that I'm able to reach the final word, so in that case I just need to return depth plus 1. Otherwise, if the current word and temp are same, so that means if the current word and the temp are same, so that means that from hot, if I'm making hot itself, so that doesn't make sense, right? So that's why I'll continue from here, right? So that's what the thing is. Now ultimately in the end, I'll just return depth plus 1. That is what will get returned. And if the new word that I'm making, if it is present and in the map, so I'll push it into my queue and I'll erase it from the map, so that I am not stuck in a infinite loop, right? So you can give me a plus 1 in the chat. A quick plus 1 from everyone would help me, right? This is a channel that is Code Era. I tried to explain you a lot. I tried to give you every possible logic for this particular problem in depth. Why DFS is used, why DFS is not used, why BFS is used, how did we decipher this problem, how did we check that okay, this problem is based on graphs, then how did we go on to find the final answer, right? So you can give me a plus 1 in the chat. You can like the video. A final clear plus 1 in the chat would help. I know I took a lot of time. It took me a lot of time to explain this problem, but I hope that the intuition and everything is clear to all of you. Thanks a lot for watching. I'll see you soon in the next live. Till then, take care. See you soon. Make sure to subscribe the channel and hit the bell icon.